A little discussion about the spider that we're going to construct. And the issue is that it's really not adaptive as far as it's adaptive to the perpendicular plane at this point on the truss system. We include an adaptive point in it. But I wanted to illustrate how it's not completely functioning as we might expect it to be in a perfect perfect conceptualization of it. So here, and this is the issue. So when we have it in a flat plane, the spider behaves perfectly fine. It's a little bit, looks like it's buried in the glazing here. That's just because this isn't offset far enough. We'll clear that up when we actually go through and make the drawing. But here, you can see what's happening to the spider. It's actually perforating through the glass. And some compensation could be done for this. But typically what these do is they have swivel points on these that adapt to that element. So it's just a matter of making sure that the spider sets back far enough so that these are well clear of that so that there can be adjustments made to come forward on the glass. But we're actually not going to bother with that complexity in the spider. It would just get in the way of creating a lot of overhead for our modeling. And take away from really our goals. And one of our goals is to kind of adjust the idea of these elements, the glazing panel sizes, the support structures, in order to create both enough structure and deal with the visuals. So if we were to actually look at this, let's just take a look at this curtain wall now in a 3D view. I wanted to show you that it really isn't very significant that these elements aren't actually behaving adaptively to the viewer. It's very hard to detect that these are actually perforating through the glazing system. So there's really no need to model them at a more sophisticated level at this point. But I wanted you to be clear about that and think about ways that once you were to move this model to higher detail, how you may have to make these components either more sophisticated or possibly using other BIM components from manufacturers that might have different kinds of performance criteria to them. And of course, it could become a non-issue if you weren't curving a wall. The geometry was just straight. So let's go ahead now and kind of take a look at what we have to do to create this spider. This is something that kind of aggravates me a little bit about using the Revit modeling environment. I've actually had to create the spider itself in a generic model environment and then import it into a generic model environment with an adaptive component. Now, of course, this has some, advantages in certain kinds of development, but in this case, it's really kind of tedious that I have to make two separate drawings, in order to bring this adaptive point in. And the reason is that when you work in this adaptive point environment, you really don't have the kind of creative tools that you have in the generic modeling environment. You can't actually just create an extrusion. So it just makes it a little more difficult to do modeling. So let's go ahead and start by opening. So we're going to end up making a generic model and then importing it into a generic adaptive model. So we're going to go ahead and make a new family, and that's going to be based on just a generic model. And we'll go to the front view, and I'll go ahead and start sketching out this idea of what this element should look like. We're going to make an extrusion, and it's going to be based on lines. So let's just go ahead. I'm going to make more lines than we need just to give us a layout. We're going to go up 1 foot just to set the depth of the thing. Let's go over, let's say, 1.5 inches. That'll give us a relatively large, robust. And then we'll come down 1 inch. And then we're going to move off this way, and I'll just click out and leave that for a moment, because what I'd like to do is just set that other idea of this thing being out another foot this way. That's the very edge of that element. And I'll just bring this down just to make it more workable. So this is the very furthest extent coming out 1 foot. We'll actually let that be the center line of the pad that goes under here. And let's give this some sort of a depth. Let's see here. We'll make this 1 inch deep. Oops, I did that wrong. And I'll just draw a few more lines in here. At the bottom of the pad, let's make this 2 inches. Now I'm going to run back up to the top. I'm just trying to figure out this can be any design you want. I'm just kind of winging some form here. Okay, that's a little unattractive because the arm is tapering. Okay, I'm not totally happy with that, but we'll just let it go for this project. So I've created a form for that. Let's take a look at that at a top elevation. We only want that to be, let's say, 1/2 inch thick. So I'm going to go 0.5 inches. We'll zoom in here. I'm not sure this is going to let me offset this. It's probably locked. Let's see if I take the constraint off. Actually, I'll do this another way. I'm going to take this item and I'm going to go ahead and unconstrain it and get it copied over here and delete this. Now I'm just going to take this and I'm going to rotate it 45 degrees. And move it, if I can grab this center point and move it to the center of here. Let's just quickly look just so you have a reference about what's going on here. Let's pull this. There we have it. You're not seeing the grid, but I'll just rotate around here. So we have this thing, this spider, this leg coming out on a 45-degree angle. I'll go back to the, and we'll make some copies of this. So we'll rotate with copy, and we'll place the center of rotation at the center. It's a little difficult to grab. And we're just going to do 90-degree rotations now because we've already established the 45. And I'll go back to the 3D view. And now you get an idea of what this particular spider looks like. And I probably wasted a little bit of time because I actually should have done this with the pads in place. So I'm just going to go ahead and I'll redo that again because we really need to create the pad that we need. So I'm going to go to the reference level again and come out here and create an extrusion based on a circle. We'll make that a 2-inch pad. I'm just going to move this a little bit if it'll allow me. It's not allowing me to move it. I don't know why that is. There we go. I'll just move this in. And then complete that. And we'll go to that on the front view. We might just leave that buried in there like that. That might look more attractive. So we'll go back up to the reference level. We'll grab both of those now and we'll copy them. You guys probably know how to do this with a better shortcut than I do. All right, so let's just look at this again at the 3D view now. And the only thing that's disturbing me is the way this comes together. There's no cylindrical kind of connection at that. So we'll just make an element there. Come back up to the top view. I'm at the ceiling plane. That's why that wasn't showing up. All right, so we're going to create another extrusion. That's a circle. And we'll go to the front elevation to set the length here. And let's just take a look at that again. All right, now I'll render it so it gives a little shadow to it. Okay, so that's just the basic idea of how we go ahead and create a spider. And the next thing we're going to do, and I'll put that in the next clip, because we're going to then import this now into another generic model that'll have an adaptive point to it before we bring it into the full panel model. Let me just save this with a name. We'll say this is a family, and I'm going to call this spider frame. Video. And it's spider framed to designate it as being not the adaptive spider itself, which we're going to add in the point in the next clip.